Hey, welcome back. In this video, we're going to go over how to create lights, how to use lights, and we're going to go over some of the most basic parameters and some of the common parameters of light properties to be able to control these lights and render things out in more interesting ways. So let's go back to rendering here. Let's hit Shift and Q on the keyboard to do a quick render, and this is what we have. Because we haven't created any lights in this scene, what we have is a default light, the automatic default light created every time we create a new scene in 3ds Max, and that's the kind of light that's lighting up our scene. Very unrealistic, it's not very pretty, and not very nice. So we need to go ahead and change that. Let's close this render window, and let's start to create some lights. So where can we create lights from? Well, if you go over here to the Create panel, you can see you can switch from geometry over to lights. So click on this icon here for lights. And we're going to have two different kinds of lights. If we go to this drop down box, we're going to have photometric section of lights and then a standard section of lights. Let's go to standard first. So click on standard. And under the object type rollout, you're going to see 8 different types of lights. We have a target spotlight, a free spotlight, target direct, and so on and so forth. What I'm going to do is create these lights one by one, and we're going to go ahead and have a look at them and see how they all work and how they're different from each other. So let's click on the target spot. Now we can go ahead and create a target spotlight in our scene. So just go ahead and left click and drag anywhere, and you're going to see 2 objects created. Before you let go of the mouse button, you're going to see 2 objects. There's this sort of cube that our mouse cursor is controlling, and then there's a sort of cone object that's located behind the little cube object. So let's place the little cube object somewhere in the middle of our teapots here, next to this purple teapot in the center. And now everything's going to go dark. The reason that happens is because since we introduced a new light into the scene, 3ds Max turns off and deactivates the default light that we saw earlier. Click on the right mouse button to end the creation process for this light. Now hit W on the keyboard to activate the move tool, and let's go ahead and move this light upwards like this. You're going to notice a very particular behavior here. Everywhere that we move this cone, which represents the actual light itself, it's going to follow this small yellow cube on the bottom here. The small yellow cube is the target point of the cone light, or this spotlight here. So everywhere where that yellow little cube is located, the spotlight is going to go ahead and face it and look right towards it. That's why it's called the target spotlight, because the spotlight that's targeted. So let's just place the spotlight somewhere up here, for example. And let's do a quick little render here. Shift Q. And this is what we have. The default light, like I said before, is turned off. It's no longer here. All we see is the effects of the spotlight. And the spotlight is very similar to something like a flashlight or a theater spotlight inside of a movie theater or a play theater. Let's close this window out. Let's look at some of the options that belong or pertain to this spotlight. To do that, we'll go over here to the Modify panel. So click on the Modify panel and you can see all the property rollouts here that we can go ahead and adjust. And there are a lot of properties that we can go ahead and adjust with this spotlight. So let's look at some of the most important and basic ones. Okay, now the first one up here under general parameters is the light type. This checkbox where it says on allows us to turn the light on or off. So we can turn it off by unchecking the box, or check the box back on and turn the light back on. We can also go ahead and change the light type to the different light types in 3ds Max. If we change our mind and we don't want this light to be a spotlight, we can change it to a directional light, or we can change it to an omni light. And we'll talk about directional lights and omni lights once we finish talking about the spotlight. Then we have this little targeted option. You'll notice that it's checked off right now. If I check it on, which was the default option that was on before, we have the little yellow target cube over here that the spotlight's always going to face and look at. If we turn off this option, the spotlight no longer has the little target, which means that it's no longer going to face a particular target. We can now turn and rotate it and make it look wherever we want. So let's make it targeted again. Then we have shadows parameters, and basically what we can do is we can turn shadows on or off. If I do a render, you'll notice that there's no shadows in the scene. These teapots are not casting shadows onto this green floor. That's not the way that things work in real life. So if you want this light to cast shadows, you have to go ahead and turn this option on. Once we activate the shadows option, you'll notice that the teapots are now casting shadows in our scene. So it looks much more realistic. So what kind of shadow types can we create in 3ds Max? Well, if we click on this drop down box in the shadows area of options, you notice that we have quite a few different options for shadows. Advanced ray trace, segmental ray shadow maps, area shadow maps, regular shadow maps, and ray trace shadows. The main shadows here are area shadows, shadow maps, and ray trace shadows. So what's the difference between the two? Area shadows are the ones that look the most realistic. They're the most physically accurate, and they look the nicest. They tend to mimic the way that shadows work in real life a lot better than any other shadow types. The problem is they take longer to render, and you notice that they do come out a little bit grainy. To fix that graininess, we have to go down here to the area shadows rollout, and over here we can change, for example, different attributes like the shadow quality. So the more we increase the shadow quality by giving this a higher number than 5, it's going to start to look better and better. The problem is your render times are going to slow down by quite a bit, especially once you get to very high quality settings. So you want to keep that in mind. The trade-off here is that the area shadows look great, but take longer to render. Now if we switch over to shadow maps render extremely fast. And they can look pretty good, as you can see. The problem with shadow maps is that if you're looking for total physical accuracy, you're not going to find those shadow maps. Shadow maps are the least physically accurate shadow types that you're going to be able to get. So they're not very physically accurate, and they can't do certain things like transparency shadows and things like that. They can't do ray tracing effects and so on and so forth. So you're going to be stuck in that regard if you're going after complete physical accuracy. For all other applications, though, shadow maps are pretty useful and they render fast. Then we have ray trace shadows. Ray trace shadows are going to be physically accurate shadows. They take longer to render. As you can see, they create these sharp shadows. So if you're looking for those kinds of sharp shadows, go ahead and use the ray trace shadows. And also note that ray trace shadows take a little bit longer to render than shadow maps. I'm going to go ahead and switch back to shadow maps since they render the fastest. Let's look at some of the other settings that we can affect here for this light. So I'm going to zoom back out a little bit so we can get a better render of this whole area. And I'm going to go here to the next rollout, which is intensity, color, and attenuation. So let's go ahead and open up that rollout. You're going to see that we get a few parameters here that can control different things of the light. For example, multiplier, which is by default set to 1, sets the actual brightness of the light. So if I switch this to 2, which is going to be 2 times brighter than before, and do a render, you notice the spotlight is now much brighter than it was before. Let's switch this back to 1 so we can see this a little bit better and it's not so blown out. Over here we have a color box, a white color box. If we click on that, we get a color selector window, and we can change the color of this light to anything that we want. So if we want it to be warm sunny yellow, for example, we can do that. So now when you render, you see that it gets this sort of yellowish tint to it, and we can choose pretty much any color that we want. So let's set it back to white. Then we have decay. What is decay? Well, decay is a little bit complicated to explain, so I'm just going to give you the short explanation of it. Lights in the real world, in real life, work by decay. Light decays over time and space. That's an actual real law of physics, so to speak. So what happens is, if you go in real life, you go outside with a handheld flashlight that you got at your local hardware store, and you flash the flashlight at your hand at night, your hand's going to be lit up pretty brightly because your hand is right in front of the flashlight. However, if you remove your hand and you hold the flashlight in the same position and you try to light up the side wall of a building that's 2 blocks away from you, chances are the flashlight's not going to be able to affect the building at all. That's because light decays over time and space. The farther something is away from light, the less the light's going to be able to affect it until eventually it can't affect it anymore. So if we click on this drop down box, we'll see that the default option was none. This means that there's no decay. Light rays or light energy in 3ds Max goes from the point of the light, the flashlight in the case of my example, and goes on forever and ever and ever, and never decays, never gets weaker. Then we have 2 other options, inverse and inverse square. these are going to go ahead and start to decay the light. That is to say, it makes the light become weaker the farther the light rays have to travel from the flashlight or the point of the light. If we select inverse square, that's the one algorithm that's going to follow the most similar decay method that mimics real life. So if you want to go ahead and create lights that are the most realistic, that mimic lights in real life, then you want to go ahead and select inverse square. Now once we do that, you'll notice that the light gets very dim. That's because once we're using decay, we have to increase the multiplier by quite a bit. So let me increase that to 5, make the light 5 times as bright as before, and you'll see that it starts to become more visible. So we may need to increase this to more, say 20. So now the light's 20 times brighter. And you notice that the light is located up here somewhere, and this area that's closer to the light is more brightly lit than this area that's farther away from the light. That mimics the way that lights work in real life. So if you're going for realism, you always want to use decay with a type of inverse square with your lights. So that's very important to remember. Then we have other spotlight parameters here that are more arbitrary, and other parameters that you may want to adjust. For example, shadow parameters here, we can create more shadow parameters. The default color of shadows is black, but you can actually change that. You have complete control. You can make blue shadows if you wanted to. A little bit hard to see here, so let's make this into a very bright blue, and it's still a little bit hard to see. Let's see if we can zoom in here and see this a little bit better. So what we want to do is go up to intensity, color, and attenuation. Start again in 3, 2, 1. It's a little bit hard to see the shadow color change right there. So let's go back up to intensity over here and take the decay off, put that to 1, and change the multiplier, the intensity of the light, to 1, and do a render. Now we can clearly see the effect. The shadow is now a different color, the color that we chose down here. So if we want to make it green, for example, you can make it green. So you have complete control over your lights. You can make them as realistic or as fake and unrealistic as you want. It's really up to you. So let's switch that back to black. So you have different parameters and things that we can adjust here. And those are the most basic parameters right there. How to activate shadows, how to switch your shadow types, how to change the colors of those shadows, how to change the color of the lights, the brightness of the lights, give the lights some realistic decay, and so on and so forth. So now let's move a little bit quicker. Now that we saw the parameters for this spotlight, we're going to go ahead and start to create some of the other lights. But we're going to move a little bit quicker. Let's select this light and hit delete to get rid of it, and we're back to the default light, as you can see. Let's go back to the create panel, and let's see some of these other lights. Free spotlight. Let's go ahead and create one of those. And there it is. Right click, and let's move it up because it's underneath that ground plane or that floor. So what's the difference between the target spot and the free spot? There's only one main difference. If we go to the modify panel, we'll see what that difference is immediately. The free spotlight doesn't have the target parameter checked on by default. The target spotlight does. So this is a target spotlight, and if I uncheck that, this is a free spotlight. That is the only difference between those two types of lights. All the other parameters down here in the rollouts, like the intensity parameters, shadow parameters, and so on and so forth, are exactly the same as each other. So there's really no point in explaining these parameters to you because I just did with the target spotlight. So let's delete this light. Let's go back to the create panel, and now let's look at these two lights down here, target direct and free direct. Let's click on target direct, and we'll left click here, and you notice that it works just like the target spotlight. It creates this little targeting cube, or this little cube, which is going to be the point of interest or the target for the direct light. So let's place this somewhere around here, and right click to end the creation process, and let's move this direct light up here. Okay, so here's our direct light. So what's the difference between a direct light and a target light, or a spotlight I should say? Let's go to the modify panel. Most of the parameters are exactly the same. For example, if we go to intensity, color, attenuation, we still get the same parameters as a spotlight. We get a multiplier to control the brightness, we get a color box to control the color of the light, we get decay parameters, We also get shadow parameters. We can choose what kind of shadows that we want, and it's the same shadows as the shadows that were available for the spotlight. So what is the major difference between this directional light and the spotlight? Well, the main difference is that the directional light shoots out parallel light rays. That mimics the light rays that come from the sun. So this light is best suited for when you have an outdoor scene and you're trying to mimic sunlight coming from the sky. That's basically what this light is good for. Okay? And the great thing about it is that the icon doesn't really determine where the light's coming from in terms of distance. For example, if this icon is located right here and there's objects behind the icon, they're still going to be lit up by this light. If you have a spotlight and any object that's behind the light will not be lit up by the spotlight. And that's what it means by parallel light rays. These light rays are coming from infinity. Even though the icon is located here, the light rays are actually coming from an infinite distance up there. The only thing this icon really controls is the orientation of the light rays. So wherever this arrow, this huge white arrow icon is pointed at, that's where these infinite light rays are aimed at. So just keep that in mind. Let's delete this light and let's move on to the next light. Let's go back to the create panel. Down here we have an Omni light. Let's go ahead and click on that and create an Omni light. Right click to end the creation process and let's move it up here. Okay, so what's an Omni light? Do a quick render and that'll pretty much answer your question. An Omni light works like a light bulb. It basically shoots light rays in every direction, up, down, forwards, backwards, left and right, and everywhere in between. So it works just like a light bulb. A light bulb shoots light rays in all directions. So the Omni light is best suited for things like, well, like I said, light bulbs. Let's go to the modify panels and look at the options. As you can see, the options are virtually identical to the spotlight and the directional light. We can, again, we have the intensity, color, and attenuation rollout just like before. We've got shadow parameter rollouts and so on and so forth. We can turn on shadows. So now you can see shadows are being projected in all directions. That's because this light is located here in the middle, just above these teapots. And that's the Omni light for you. So let's go ahead and delete that. And now let's move on to another one that's a bit more interesting, the skylight. Let's go ahead and click on that and let's create a skylight here. And let's move it up. Now the position of the skylight isn't really going to make a difference. You notice it has a very unique icon. What is a skylight? Well, the skylight is a pretty unique light in 3ds Max and it's very interesting. What the skylight tries to do, it tries to mimic an environment, a sort of atmosphere around your scene. And the way it mimics that is by shooting lights from all different directions from the make-believe or imaginary dome or environment atmosphere around your scene. So let's go to the modify panel. Let's look at some of the options. And there's not a lot of options here with this skylight. It's pretty simple to use. Let's do a quick render and you're going to see what you get. Looks very cartoony, very 2D. There's no shadows or shading or anything. It's just flat shading. This is what the skylight's going to render by default. So let's change that. If we go over here to its parameters, we can turn the skylight on and off. We can also change its brightness using this multiplier parameter. We can also change the sky color. So right now it's set to white. So everything's just going to render with a white hue. Okay. We can plug in maps, and I'll talk about that in a moment. And then down here is probably one of the most important parameters for this skylight, the cast shadow parameters. Let's check that on. Now let's do another render. Now I paused the video, that's why you saw that little jump in rendering. I paused the video and then I brought it back again. This is taking forever to render. You'll probably notice on your system as well that this is taking a very long time to render. But you can start to see here that the quality of the render is simply beautiful. So what's going on here? Well, what's happening is that the shadows for the skylight require a lot of processing power and a lot of processing time. That's why they look so good. By default, the rays per sample here is actually controlling the speed of this render. It's set to 20. 20 is a lot. You really don't need 20 unless you're doing a production render or you're doing your final nice render that's supposed to look really good. When you're testing or just experimenting, you don't want to have the rays per sample set to 20. Go to something lower. If we drop it down to 5, for example, and now we do a render, you're going to notice it renders a whole lot faster. But you're going to notice that there's this artifacting coming in here. We can see this graininess in the shadows. That's because the shadows were reduced in terms of quality. So now we have reduced quality in the render, but we have more speed. Okay, so that's the skylight. The skylight tries to mimic this sort of environment around your scene. So let's look at a couple of more parameters with the skylight to see what we can do. We can change the sky color here from white to say blue, and now everything is going to have this bluish tint to it. Now the effect is very strong here because I chose such a strong blue color. So let's change the blue to back to white, and let's do a render again, and there we go, we're back to square one. I can hit escape to cancel the render and stop it from continuing if I need to. Down here we have a map parameter. If we click on this none button right here, we'll open up this material map browser, and we can actually plug in images to the sky color map. So for example, I can go ahead and choose an image such as, let's see, let me pick noise. Now there's noise map plugged into the actual map parameter. What this means is that when I render, the noise map is going to affect the way that this skylight lights up my scene. As you can see, now I have these like sort of shadowy type figures or pattern across my scene, and the map has actually totally affected the brightness of the scene and where certain areas are brighter than others, which is pretty interesting because you can mimic effects of an overcast cloudy sky and so on and so forth. So you can use this map parameter to your advantage to create some very interesting effects. You can also right click on it and you can hit clear to go ahead and get rid of it. So these are the parameters, all the parameters for the skylight properties, and the skylight again is best suited for creating a sort of environment type feel to your scene, a sort of sky effect with light coming in from all over the sky and the atmosphere in your scene. Okay, so we're done with the standard lights. Let's delete the skylight and let's go back to the create panel, and for lights let's switch from standard and let's go to photometric. Now you notice there's not many photometric lights, and one more thing I want to talk about, actually edit this out of the video, edit this part out of the video. We forgot to talk about the mental ray stuff. So start again in 3, 2, 1. Start again in 3, 2, 1. Okay, so let's go back to the create panel over here, and two last lights that we didn't look at was the MR Area Omni and the MR Area Spot. No, this doesn't mean Mr. Area Omni and Mr. Area Spot. MR stands for Mental Ray. Mental Ray is a plug-in renderer that's included with 3ds Max. It's not the default renderer, so it's not going to be active by default. In the rendering video, we talked about the Mental Ray renderer just a very small amount, and I showed you the options in the render setup dialog where you can switch from the scanline renderer to Mental Ray. So what's Mental Ray? Well, Mental Ray, I'm not going to get too far into it, but Mental Ray is a production renderer used heavily in the industry for all kinds of rendering work, both photorealistic and non-realistic effects. These two lights down here are lights that are specially used when you're using Mental Ray. The Area Omni light works just like the 3ds Max Omni light. The only difference is that it's going to cast area shadows. And we looked at area shadows earlier when we were switching our shadow types from ray trace shadows to shadow maps and to area shadows. They're more realistic, they take longer to render. The Mental Ray Area Spotlight is the same. The only difference is that it's not an Omni light, it's a spotlight just like the free spotlight up here or the target spotlight. So that's just what those two lights are down there. Now let's switch from standard to photometric. What are photometric lights? Photometric lights are more realistic lights meant to be used when you're going after very high level of realism in your renders or animations. They use IES profiles or photometric profiles to create more realistic lights. These are perfect for if you're working on architectural visualization or other design visualization tasks that require photorealism or the utmost photorealism. So we have a couple here. We have target light and we have free light. These are the two main photometric lights that you're going to be using. And they're both exactly the same. The only difference between one and the other is that this one here, the target light, has a little target point, a little yellow cube that it follows, and a free light doesn't. So let's go to target light, and now we get this photometric light creation dialog that opens up. It says you're creating a photometric light. It's recommended that you use the logarithmic exposure control. Exposure control settings can be adjusted from the environment and settings dialog. Would you like to change this now? So what is it saying to us? What is it asking? Well, there's different exposure controls that we can use in 3ds Max. By default, no exposure control is active, so there's no exposure control happening in our scene by default. Now, when we use photometric lights, 3ds Max suggests that we use exposure control using the logarithmic method because it's going to give us more realistic results. So let's go ahead and click on yes. Now we can create our target light. So let's go ahead and left click and drag. There's our little targeting cube. So let's place it somewhere in the center of the little scene here. Right there is fine. Let's right click to end the creation process, and let's move this photometric light up. And you notice it just looks like a little sphere. Now let's do a render, and you'll see what we get. Looks a little bit more realistic, has a more realistic tone to it, as you can see, and it looks pretty interesting. Let's go ahead and close that window. We can make this look a lot better. Let's go ahead and switch over here to the modify panel and see what some of the parameters for this light do. Now you notice that the parameters are radically different from the parameters of the other standard lights that we were using before. Photometric lights have a totally different set of parameters and are totally different to use. So let's look and see how we can use these to create a realistic little light setup here. The first rollout up here is the templates rollout. We can actually select these presets or templates of real life light sources. For example, bulb lights, we can choose 40-watt bulbs up to 100-watt bulbs. We can also create halogen lights, recessed lights, fluorescent lights, and other lights. So we have several presets here to choose from. Let's go ahead and experiment with some of these different light setups. Let's go ahead and set up, select, say, a 100-watt halogen bulb. Okay, let's do a test render, and this is what we get. It's not very bright. We need to go ahead and increase the brightness of that. So let's go ahead and let's do that. Shit, where do we do that? Oh, right. Starting again in 3, 2, 1. If we go ahead and scroll down here in this panel, we'll see the intensity color attenuation rollout down here. This is where we can change the intensity of this light. Now you can choose a lot of different things here. For the color, we can use this method here by damn. Start again in 3, 2, 1. We could go over here to color and choose different presets for the color to change how this looks. So you can see there are a lot of presets: fluorescent, halogen, incandescent, and so on and so forth. We can also choose it by choosing the actual parameter for Kelvin here, where we can change the warmness or the coolness of the light. We can also affect the intensity in several different ways here. For example, we can go down here and change it from 100% to 200% to make it twice as bright, and it starts to brighten up. So let's change. I'm going to just jump to 1000% to really make this bright, and we can start to see it take effect. Let's go ahead and enable shadows for this light so it looks better. Let's go up here in the general parameters and click the checkbox for shadows to on. And now we can start to see that we have shadows in our scene. Let's switch over to area shadows so they look more realistic. They are going to take a little bit longer to render. In this case, not that much. Okay. Now we have a lot of different parameters. We can change the way that the area shadows work by changing the shape of the light. So by default it's at the point, but we can also change that to say sphere, and it will change the way that our shadows are projected here. It's also going to take a little bit longer to render once you choose these other shapes, so you want to keep that in mind. So it's taking a little bit, it's taking its time to render here. I'm going to go ahead and hit escape to cancel that render out. And you could go ahead and experiment with these different shapes to get different shadow effects. We can also go down here to area shadows and change the quality of the area shadows. For example, down here, shadow quality, reduce it to something lower than 5 if you want it to render faster. Of course, that's going to introduce artifacting. It's not going to look as nice. So you can experiment with these different templates and choose different ones just to see what you get. For example, this template chooses this creates a pretty interesting light effect here. For that one, I chose the Recess 250 watt wall wash web. Let's go down here to the intensity and reduce that intensity by half. So I'm going to go down to 500%. And you can see how it starts to come out. I'm going to switch over here to Kelvin just to give it some warmness, and you can see how we start to come up with some more interesting light effects. This looks pretty dramatic and very interesting. You can use these types of photometric lights to create all kinds of interesting environments and effects. It's really a great way of lighting up your scene in 3ds Max. I strongly recommend that you use these photometric lights whenever you can. Okay, so that's going to do it for photometric lights. Let me close that. Okay, let's look at one other interesting thing. Let's look at real-time shadows in 3ds Max 2009. There's something very interesting we can do with this in the viewport. We can actually see the shadows being projected by this light. So how can we do that? Well, we need to do a couple of things. If you right-click to open up the quad menu, we can go up to Viewport Lighting and Shadows. That opens up another quad menu. Go to Viewport Shading, which opens up another set of options, and click on Best. This is going to turn best shading on. You'll notice that the lighting changes in the viewport, but we still don't have shadows. Let's go ahead and change something else too. Let's go ahead and right click. Make sure that you have this light selected. If not, go ahead and select it. Right click to open up a quad menu and go to Viewport Lighting and Shadows. Then go to Select Lights Displaying Shadows. This means that any light that you have selected, when you click that, it's going to cast shadows. Now we can't really see that right now, so let's go ahead and increase this intensity by more, and we're not actually going to be able to see it right there. So let's let's demonstrate this with a fucking spotlight, okay? Oh, it's still recording? Damn. Okay, edit this out of the video, edit this out of the video. Start again in 3, 2, 1. Let's go ahead and let's select this light and let's delete it. Now we're back to the default light. Let's go back to the Create panel, switch to Standard Lights, and let's pick a target spotlight. And let's just place this guy anywhere around here. Somewhere back here is fine. Okay. Alright. Now what we're going to do is we're going to go ahead and take advantage of 3ds Max 2009's ability to project real-time shadows in your viewport, which is actually a pretty neat feature. So how can we do that? How can we project shadows in the actual scene here? Well, first of all, let's go to the Modify panel for this spotlight, and let's turn shadows on. Now you notice that shadows only get activated for the render. It doesn't get activated for the actual viewport. So how can we activate shadows in our viewport? Well, it's actually pretty simple. Let's right click to open up a quad menu, go to Viewport Lighting and Shadows, and go to Viewport Shading. Make sure that your setting is set from off, which is the default, to best. Okay? Once that's done, in the same menu, you want to go ahead with the light selected, the spotlight in this case. Click on Select Lights Displaying Shadows. Once you do that, your light is supposed to display shadows, which it's not doing for whatever stupid reason. fucked up. Start again in 3, 2, 1. Now make sure that your light is selected. Right click to open up a quad menu. Go to viewport lighting and shadows and make sure that under the viewport shading options it's set to best. Then in the same options with the light selected, you want to go down here to where it says enable viewport shadows selected. Once you do that, you can see that now we have real-time shadows activated in our viewport. This can be extremely useful for getting a good idea of your shadows, where your shadows are, and how your shadow is going to be projected based on the angle of the light in your scene. So it's a great feature. I suggest you take advantage of it if you're going to be working with lighting in 3ds Max. Finally, the last thing that I want to talk about is how to select and manipulate this light. If you notice up here in the main toolbar, we have this button here. It says select and manipulate. Well, if we go ahead and select that with this light selected, you notice that these manipulators pop up. Down here we have these green rings that if you hover over, they turn red to show you can manipulate them. We also have this blue ring here with a few other handles. So what do these different manipulators do? Well, for the spotlight in this case, they control different things like the cone angle, for example. I can go ahead and select one of these green rings and I can interactively change the size of the ring. This changes the umbra, it changes the cone angle of the light, and several different things that affect the way that this light actually affects the scene, as you can see. So now the edge of the light is much softer as opposed to how it was before, where it was harsher. We can also rotate the light here just by using that manipulator. We can also change different things here like the roll angle and things like that. So that's what the select and manipulate button does up here. Let's go ahead and unclick that. Okay, so that's pretty much going to cover all the basics of lighting in 3ds Max. You should have the knowledge necessary now to go ahead and start to set up some basic lighting in your scene and get some kind of lighting going.